Okay, morning everyone. Okay, this morning we're going to quickly look at the preview for the week and what is ahead. This week you will see we are starting to look at use case design. So the section which we're going to cover, we'll briefly look at. This is the first module, which is analysis and design overview, which is really just giving us a bit of an overview of the work. It also does a comparison between analysis and design at some point. Okay, so they quickly mentioned to us what is the inputs to analysis and design and what is the expected outputs. The outputs in this main case is the design model, architecture document, and a data model. Okay, so our architecture document tells us what is the architecture and structure for the project going to look like. The design model is now going to reflect the classes based on your actual design. Your data model will be almost a stripped down model of your design model, which only focuses really on your data elements. Okay. So then they quickly mentioned to us the purpose of analysis and design, also quickly to transform the requirements into a design of a system to evolve a robust architecture and then to adapt the design to match our implementation environment and designing for the performance of that. Okay. So then there's a mention quickly of when the workflow this happens. Now design is this portion where we focus on refining the architecture. Now refining the architecture is taking your current architecture and sharpening it in areas and saying, but this still needs to be addressed and made better for the performance or so on. Then it's looking at defining the components. This is now where class design and use case design and subsystem design falls under. And then there's designing the database. Okay. So then there's a quick comparison between the analysis and design, where analysis is really focused on us understanding firstly the problem. We now are transgressing to understanding the solution and designing for that, where we're focusing on the operations and attributes, looking at the performance and getting closer to the actual real coding, the implementation environment. Okay, where we're then also looking at the object lifecycle, and this is then becoming a larger model where we're focusing on also the non-functional requirements. Okay, what is non-functional requirements? Those are things like your performance, security, the other things which is not part of your functionality of your system. Okay. Then I quickly mention who is responsible for the different tasks and role in this. Okay. Now, then they go so forth to say to us, but when we're doing this analysis and design is not really a top-down or a bottom-up approach. It's more matter that we're going from our use case perspective to our analysis classes or analysis class diagram. We can go upwards where we're going to a higher level place where we're focusing on the subsystems, or we can go lower where we're starting to focus on the actual details of your classes. That is where we're looking at our design classes. When you're going higher, what do you see? You actually see less detail. So that is why we're saying that we're starting to look at the packages, the subsystems. But when we're going lower, we see more detail in terms of the actual classes. Okay. Then there's a quick mention about the iterative nature of analysis and design. There, for our first scenario, we can have first realization, and we can have many different iterations on top of that to develop it. Okay, then there's quickly also mention about architecture. Okay, when we build a building, what do we use to tell us what the building is going to look like? The blueprints. Where is the water lines going to be? Where is the electricity going to be? Where is the network points going to be? today in a time when we're building smarter buildings and smarter cities, we are very much looking at the actual architecture of that. How is that going to be interlinked and structured? Now, this is also important for when we're focusing on software systems, that we look at the architecture, because architecture speaks about a set of significant decisions about the organization of now our software system. Okay, what is these significant decisions? Firstly, the selection of our structural elements. So what type of elements are we going to have? How is it going to be structured? And what interfaces are they going to have? Then the behavior as specified in our collaborations amongst those elements. It's talking about how can they collaborate? What collaboration is available based on your architecture? Okay. Will the behavior be different, or the way in which they can communicate be different based on the type of system? If we're talking about an embedded system compared to a mobile system. Yes, they will be different. Why? Because even your type of classes between the languages and the implementation areas is different. So that plays a major role. So now, thirdly, the composition of these structural and behavioral elements into a larger system is affecting our architecture, and then your architectural style that guides how is this going to be developed and how is it going to be structured and put together. Okay. So then they mentioned to us that your architecture underpins the whole design, implementation and coding process to this. So that's why they say to us, but your architecture is the biggest area of this. Because if your architecture changes, it is going to have an effect on your design, on the implementation, and finally on the coding. If you have an initial application, and that application was seen that it's going to be for an embedded system, is it going to have an effect on your code and implementation design? Yes. If they come to you and say, but we want to extend this application so that it also works on a web system, what does it mean? The scope of your architecture becomes bigger now. So that in essence means that our design, the implementation, and finally your coding is going to be bigger, because it's also now going to focus on that. Okay. So then they quickly mentioned to us the different views which we can use to see really our software architecture and how the system is put together. For example, we can mainly focus on the use case view, which everybody is really focused on, because they are looking at, number one, the functionality which is provided by that use case. Then we also have a logical view, that's where the analyst and design is in essence looking at your structure of your system, how these classes is working together. That's where the class diagram plays a very big role in terms of this. Then on the implementation view, you have your programmer, and they are looking at the actual software management. How these interfaces, how will they be put together in a bigger system. There's also the deployment view, where the system engineer is looking at how am I going to put this thing in the bigger picture of our company, organization. Okay, so take for example, if you had to develop like Inatus, what is Inatus? Who knows? Okay, Inatus is one of the systems which is used to track your vehicle registration and to register you as an owner of a vehicle. All of that whole thing is managed in that for South Africa. So when you develop that, every municipal area or many places of that have their own place where you go and you register your vehicle. Now, that system needs to be linked to give it to a bigger system and all of that. So that plays a role in terms of your deployment. That's why our system engineer is looking at how is this bigger thing fitting together in the whole system. Okay. Then we also have the process view where the system integrators is looking at the actual performance, the scalability and throughput of your total system in terms of the data and how am I going to send and process data from one request to the next. Okay. Take for example, if a company places an order, who is going to see it next? Must it go up? The manager sees it before it's processed. That is also where the process view plays a role. Okay. So there's a very short review, few questions at the end of this. Then you'll see there's another module on actually covering use case design, where it introduces to us. And now as part of this use case design, we said is part of the section on defining the components. Now when we going through this, the various things which we get as inputs is our design subsystems, the supplementary specifications, your use case and design classes. And it's going to go that we go to our use case realization. And we can expand it and refine it a bit more. Okay. So in essence, when we're working in use case design, we're initially taking our analysis classes and we're expanding it a bit more, adding more detail to this. For example, in analysis, we might have just had a boundary class. But how is that reflected in design? Is it only going to stay one? What is now going to happen? Okay. In analysis, it was nice and easy to say, but we just have one for that to fulfill this role. But in design, this is now going to be affected by a number of things, the implementation language, the implementation environment you're working for. Okay. So you'll see the quick steps to use case design. It says to us to develop your use case realization. What is a use case realization and why is it helping us here again? Because it gives us the traceability again from our design to the initial requirements use case. So that when we create our design sequence diagrams and class diagrams and we creating the realization, it says to us, but ultimately these classes that I have here allow me to fulfill the requirements which comes from a requirements use case. So then it describes the interaction among your design objects that is done through the creation of your design sequence diagram looking at it. Then we can go and simplify our sequence diagrams using subsystems. Okay, what is a subsystem? Have you used subsystems before? Okay. What's a namespace in a library? In essence, it's a subsystem because it's almost like a small system fulfilling a specific role and functionality for you. Okay. So you can go and simplify your sequence diagrams just by using things like subsystems. Then there's a mention about describing your persistence-related behavior related to this. Okay. So then there's quickly mention again about the use case realization. Okay. So to refine your use case realization, you might look at the participating object, who's participating in this use case. Then you might go and allocate the responsibilities appropriately among those objects. We'll look at this again when we create a design sequence diagram next week. Okay. Then we're going to model the messages between those objects. Then we look at the processing resulting from those messages and later on looking at the class relationships. Okay. So we'll more focus on that when we create the class diagrams also. So as part of the refinement steps, we're going to look at each object that participates in the flow of your use case and then refine it. Okay, so we represent each participating object in a sequence diagram. So every object which is participating in your sequence diagram will be represented there as lifelines. Okay, so as we continue, we can also incrementally apply different patterns and architectural mechanisms to introduce possibly even more classes to the system. Is this the fact that you add more classes to a system making the system more complex or easier? Why do you say more complex? The fact that you add more classes, does it break down sections into smaller pieces, or is it just going to leave it in big chunks?
If not strategically used, it gives us complexity. If strategically used well.
Because if you use it strategically,
yeah,
you can structure it appropriately
yeah.
to use it. Okay, so that's why these architectural mechanisms and patterns comes into play, because you can then use specific patterns and mechanisms to fulfill roles for you. Okay. Now, that helps you later on when you design for that, is that you actually might get to a place of having a few complex classes, but then restructuring them so that you actually have a few more classes, but more manageable operations. Okay. So then there's also quickly a mention about how do we represent subsystems and proxies and all of that in terms of the interfaces. So if we have an interface, what does it mean to us? Interfaces mentioned quickly here on the left hand side. It says to us, but we cannot really represent any messages drawn from this. Where do we see interfaces? When we're talking with other devices and other subsystems. Okay, where do we see proxies? Proxy can be seen if we're trying to represent a specific subsystem. If we have a complex area or a number of classes and we can place it inside a subsystem, we can go so far to model this. If I have my proxy to the subsystem, I can go and model messages inside of this. But when we represent interfaces, we should not represent arrows again going from the interface onwards to the actor or to other areas. Okay. So it just stops at the interface. You don't model the internal behavior in there. Okay. So then there's quickly a mention also about how do we see it when we're incorporating subsystem interfaces, and when we, for example, we might have a boundary class for our billing system. We might then go and say, but I have an interface to this billing system, and it allows me to go through to my subsystem or another system for the billing system. Then they also mention for the course catalog system. Then there's quickly a mention about how does it look if we now have our initial sequence diagram, and then but what are we seeing here is I have my course catalog system. That was another system which they tried representing there, and now they show, but now they have just the interface to this system. So they have replaced this system with the interface to the system. So that's why it's an I-course catalog system. And now we are just seeing a message which is passed to it. We don't see the internal details in that interface. Okay. Then there's also an example of how do we see it if we incorporate subsystems in our class diagram. Again here, we're seeing that interfaces being added to interact with the rest of the classes. Okay, so then there's quickly a mention about incorporating more logic into subsystems. Why would you do this? Why would you incorporate subsystems?
To leverage some functionality within the interface.
You're saying to leverage some functionality within that interface? But more detail about why. What can you have inside a subsystem? Will it be another system or a number of classes? What are we going to see? We could almost have the situation of just having a subsystem, which is mentioned by this bigger package. And inside the package, we can have a number of classes fulfilling a role and a purpose for you. Okay. So that's where it's coming to play in this. Okay, so when will we encapsulate more of our behavior into a subsystem? If that behavior occurs in multiple use case realizations. You remember at one point we looked at the restructuring of a use case. Includes and extends. This is also a place where this can come to play, that you don't always have to just model it as separate use cases. You can model it even just at a smaller functional area and see it as a subsystem. Okay. If there's a potential for reuse, okay, if you have some of the functionality which is going to possibly be reused over and over again, then you can place it in a subsystem and just create a public interface to it. Okay. If it is complex and can then easily be encapsulated later on, okay. If it's a responsibility of one person or even a team of people, that makes it more manageable because you then can go and define well-defined areas where you say, but this subsystem, which we have here, must do the following. How does the following, how the internal workings work? You don't really care. You're only working and focusing on almost the external operations. If we go and say, but it must be able to do two things. The design team is only worried about how it's doing this.
So you don't do function composition on the interface?
Function composition.
For use cases?
Maybe
you want to include some part within the subsystem?
To some extent, yes, you are, because you are looking at your interface. When you're creating a subsystem, you still need to look at the interface to this. And this public declaration must go where? On the interface. So how the internal workings of that interface works, you don't really know. That's where this is nice, because from a team perspective, that one team is only working on that portion of the system. They only need the public to know. Yes. Yeah. Okay. Just want to see. Still have a bit of time. So it also encapsulates nicely within a single implementation model, because that subsystem then represents for us that area. That's where, if we look here, it says to us that we're going to use that. we're going to go and get the course offerings. How we get it is the purpose of that subsystem. Okay. Then I quickly mentioned for us a few guidelines when we're modeling with subsystems, and what we're seeing here is that we have our public interface, and there is our subsystem. So on your interface, you are going to see your public operations, public methods. Okay. So this will become available, and you can then use it in your sequence diagram. Okay. So what are some advantages of using these subsystems? They are giving us our sequence diagrams and allowing us to structure in such a way that we can make it a bit less cluttered. Okay. It can be created before the internal design of that subsystem is actually performed. So if we have a bigger use case, we can focus on the bigger use case and then break it off into sections and say, but this section I can go and do later on once other portions is completed. Okay, it also plays nicely too well with the iterations of the methodology. Okay, and it's more generic and thereby allowing us easier change of sections, because we can go and replace a subsystem if we find that there is other better ways of doing this, as long as the public methods still stays the same. You can replace the things which happen behind it. Okay. Also then there's quickly a mention about parallel subsystem development. What makes this nicely is teams can operate in parallel. Okay. So there's quickly a mention about scrubbing persistence related behavior, where we're looking at how we model transactions, writing of our persistent objects, reading of them, and actually deleting this. Okay, so what is a transaction? They quickly mention to us, they say to us that a transaction is some atomic operation with vocation of atomic operation. It's either all of this that must happen or none of it. Okay, and it provides consistency. Inside, let's say, a banking system, if you go to an ATM, where would you like to see a transaction happen? Where do you see it?
We have depositing, withdrawing. That's a key.
When you are withdrawing funds, why do you say when you withdraw funds that should be seen as a transaction? When you withdraw money, what happens? You select amount, it debits your account, and it gives you the money. But what should happen if it cannot give you the money?
That's an incomplete.
Should it still give debit your account? Should you stand at that ATM and say, but we would like, what is that slip going to say? We've debited your account with 1,000 rand, but we can't give you 1,000 rand. Who's going to break the ATM? A few people would probably break it.
Where's the money?
Have you ever been to a kiosk where you would like to buy food and you swipe your card and they then debit your account twice? That happens. What happens with the second debit order? They actually credit you again with that same money. So later on the bank will go and fix it. So what makes transactions nice? It's either all of that should happen or nothing. It should either happen correctly or not even at all. Okay. So some modeling options that we have for this is we can go and place some scripts and explicit messages in our diagrams. We can also indicate some error conditions in terms of rollbacks, failure modes, and this may even include that we create separate sequence diagrams just to model what should happen if something goes wrong. Okay. So when we're looking at our design elements that we've identified, or even your analysis mechanisms for your analysis classes, you might have a student and schedule and so on, your entity classes. If you go and say, but they are using some form of persistence, have we identified what type of persistence yet? No, that's possibly part of your architecture, but it's also part of your database design portion, where you are looking at how are you going to deal with the storage or the retrieval of this data. If we have a course catalog sitting there, and it's also saying to us that we have persistence, but we might have a legacy database, a legacy interface. What does legacy mean? We normally speak about it, someone's legacy after they die. It's almost that case. That system is still there. It's still running, but they can't get rid of it. So they still have data which is stored somewhere in this whole system and interaction. Okay. So we can then go and refine our sequence diagrams by adding scripts, which is really a textual portion in your diagram, notes and saying, but this is happening. Okay. So that can be added to your diagram to give it a bit more detail about why and what is happening around these messages. Okay. What does it mean to unify your classes and subsystems? When will you do it? Okay. A lot of times it happens that we have multiple use cases and teams developing your system, and it's not just one person, and they might discover classes which overlaps a bit. It's almost like looking at a system from different perspectives, from this side and so on. And you would discover multiple classes. Some would call it student and someone else would call it students with an S. There might be a bit of overlap. So that's why we are seeing that we are unifying this. So what does it mean? We might merge similar model elements. So if these elements are close to the same or the same even, we can bring them together and merge them. Okay. Now that also helps us to properly use some inheritance to abstract some model elements and create some structure and hierarchy. It also keeps model elements and flow of events consistent, because now you are really refining the naming of your classes, especially if there's multiple classes with close to or the same name. Because even by looking from different areas, you might get that we have a student here, but now you're discovering certain attributes. And when you're going from another use case, you also have a student, but you're discovering other attributes of that same student class. So when you merge this, you also are merging the attributes and the operations ultimately provided by that class. Okay. So you'll see at the end of this, there's a few checkpoints to use case design and class design, and all of this, which you can quickly go through. Okay. So, any questions? What you would note as part of this, it's not a very big practical unit. It's more focused on the theoretical introduction of the material. Practical will come into place when we're starting to actually create a design sequence diagram, but we're also going to look at the architecture for that, for the system.